So as Jared is plugging in, I would suggest that you go to your project packet, which has the picture of the car on the front.
Dr. Benson?
Yep.
Is there an extra project packet?
There is. There's a bunch of them here. So this is the bulk of what you're going to be modeling, are all the components of this. And so each team will get one of these things. And the first thing you get to do is kind of take it all apart carefully. You can put it back together again. Because if you break something, you buy it.
At full price, not the half.
Yeah. So anyway, these are very, very detailed. I'll send them around the last 10 minutes. They're very detailed race cars. You'll take completely apart. We'll give you a little set of tools and you can take it apart. And you'll do that as a team, and then each of you will individually build a shell of your design. One of you, we hope, will choose to copy the actual shell as close as you can. Copy the shell. So in this case, you would copy this, I think, is a 69 Camaro. Is this a 69 Camaro?
Yeah, it is.
Okay. I knew it was Camaro. 69 Camaro. So one person on the team would say, well, I'll model a 69 Camaro, but everybody else gets to choose to make the shell look like whatever you want. Right? And so at the end of the thing, you will have 6 different shells that you can put on top of a single assembly model of that chassis. So with that, Jared is going to talk about this project a year ago.
Yeah. I was with the BYU USP team, the São Paulo, Brazil team. And we started, just give you a brief overview of what we're going to talk about. Just the team members, and then some of the modeling and optimization and finite element stuff that we went through and covered. Then the mass properties of some of the parts of our car, the motion simulations, and then a brief overview. So this is me. This is some of the stuff that I did in for this course. I was the team lead for our team, and we modeled, I thought I showed on the previous slide, I did, the Formula 10 racer. It's one of my preference, because I thought it was pretty simple, but it was, at the beginning I thought it was pretty simple, but it turned out to be complex. As will all of the other cars. But it's something that, if you break it down piece by piece, it becomes much simpler. Focusing on small parts on all of it all together. So for my body, my shell, I modeled the 89 Batmobile. It's kind of a weird thing to put on a Formula 1 racer, but I thought it was pretty cool. And it was just a funny little rendering mishap. It made it look like the car's lightning. Here's Mark. He's another one of our team members from here. This is the body that we chose to use for our CFD analysis. We'll talk about it a little bit more later. But it turned out to be pretty quite cool. And Michael, he did a lot of the modeling for the front. He modeled his body after a little Hot Wheels car. It turned out really, really cool, but we had some problems with it, so it wouldn't render part of it. So we figured out later what the problem was. Ivo, the Brazilians are really big into Formula 1 racing. And so they thought this was really awesome that we got this car. But they did this one, and then Leo, this one's hard to tell, but this one's got some insane geometry up through there. He was, and then Marcus, his was the gold Beamer. It was pretty cool. And then so for communication, this year you guys will be using Team Center Engineering for a lot of your file sharing, a lot of your version control and whatnot. It wasn't working last year for us, but we worked this summer to get it going, and it's working. So we use Skype and email just to communicate a lot of our stuff, and then also the TCC collaboration tools. The TCC is Team Center Community. It's It's a website set up for this class where all of the students across the world will be able to access it. We'll have a log-on name and password. And you'll be able to, each team has their own website on it. It has a picture of the car, a calendar, a discussion board, has a place where you can upload and share files to each other. And it's a secure site that only your team will be able to access, and the TAs with the right rights. It's something on there, there's a link to an application sharing software. This year we're using Join.me. Has anyone ever heard of that? Okay, Join.me is this wonderful little thing. It allows you to control someone else's computer if they give you permission to do it. It's like screen sharing with a kick. You'll learn more about that in the lab. So then for file sharing, we also use TCC. You'll be doing a lot of it through TCE, Team Center Engineering, which is directly interrelated with NX and then Google Docs. For management, we met every week with our team meetings, and then every few days, we had the team of 6 people divided into 3 subgroups, one for each subsection of the car, the front, middle, and aft section. And we split it up that way so we could each specialize on a certain part of the car and know it really well. So for the top-down approach, have you discussed that yet? Yeah.
Just barely.
Okay. We set up the skeleton, the overall assembly of the car, in a top-down approach so that the parameters would be able to propagate from one to the other. And since we see so many parts, some of the smaller sections had to be assembled in a bottom-up approach because you have lots of parts. But those smaller sections were set up so that they would move along with in the top-down assembly. So you get a little bit of a mix, which we found for our particular application made it quite nice. This is just some of our file sharing stuff that we showed. We had our old versions, which every week each half the team would upload their files, and we would sort through them and put the old files in the older versions things, just so we could have version control. If something went wrong, we'd have something to fall back on. That's something that's really important. That's something that TCE will take care of to a large extent for you guys. For here, this is just showing some of the parameters that we use. We have our main parameters for the overall car. If we were looking at the entire assembly, we only saw these. And then those propagated down to each sub-assembly so that until we get to individual parts and which parameters they see. And then here just shows some of the parametrics of our car. It's a little bit wider. This is almost standard but stretched out wide. And then this is shrunk and stretched long. Some of the parameters showing how they work. Some of the challenges that we had, this is Marcus's gold beamer. You can see just how some of the geometry is just so intense just through there that he had to overcome that to be able to fit it over our model. And then this is one of the older versions that we had. We thought we had our parameters set right, but you can see some of the surfaces blew up. And so it took a lot of debugging to figure out where is that parameter going wrong. But something that was very interesting. So this is our first section, our front section. It's got a lot of parts, a lot of control arms, steering linkages. Our car didn't have any suspension up front, so it made it a little bit difficult to model individual parts for some of the labs. But we were able to, it's made it quite nice to be able to optimize and do motion simulation. This just shows our assembly coming together, kind of a time-lapse thing throughout the course of the semester. And then we have our final setup of the front assembly. We have it compared to here. This is the real, can't really tell, it's just a projector. This is the real thing, and this is our model. It's really similar. Here's the real thing, here's our model. It doesn't have the wires, we're going to get to that. But, yeah. And then we didn't get a picture of the back part because we had the car assembled and we realized we forgot to take a picture of it. But here's just a little fly around of the car. We'll show you how to do this in a later lab, but it's quite awesome. Topology and optimization that we did for the car. In a lab, we're going to show you how to take a control arm and optimize it so that you minimize weight and optimize weight for how much load you're bearing. In these cars, because they're toys, we don't really care about what loads you use. You just have to have some load, and then it'll show where that load is going and if it's reasonable or not. Here you can see this isn't really a reasonable solution because there's nothing right here. So that was one of our problems. But if you flip it over, you can see there's a little bit of a strut underneath this part that we had in a later version. Here's another topology optimization that I ran that does, you can see this load path going here. There's stress there and here, and that shows where the material needs to remain. So this is the final product that we came out of, the gray, and then the blue is just what the computer said needed to be there. So we were able to match it closely. So in this finite element analysis for this is one of the steering rods. You've got a little plastic piece, a little steel rod, and another plastic piece. And we found that we were able to, with just modeling a single plastic piece, we were able to meet the criteria that we needed for stress and bending, and still make it 80% lighter, which in a racing car is pretty good. But then we thought about it, and we need the adjustability associated with this to be able to adjust the steering image of the car. So that's a trade-off. You could make it lighter, you could not. That's one of the things we thought about. This is just a simulation showing the stress concentration here. This is the suspension of the back, which is really just a compliant member. Because the Formula One racer is just so low to the ground, it's just bending on this composite piece right here.
I think the bell's gonna ring, so maybe
Okay.
just punch through.
Here's just some of the mass properties we did. We showed how we could make this 45% lighter by making it hollow. And then just some of the mass properties of how the load is distributed in the car. Motion simulation. CFD analysis with a fin, without a fin, and some pictures of the car.
So labs start tomorrow. The labs are in 413 of the Clyde building. So for NX, make sure you show up to lab, and then we'll see everybody back here on Thursday. And then Friday is the CATIA lab. So
413.
So we're
413